Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick until the end of the video where I have two bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 6 to the power of x is equal to 12. Now I want to find the value of x. So the first thing I'm going to do is I'm going to take the log on both sides. So now I have log 6 to the power of x is equal to log 12. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent of b to the front of the logarithm. So this is equal to b times log a. So log 6 to the power of x, I can actually move this to the front. So I'll have x times log 6 is equal to log 12. And now what I'm going to do is I'm going to divide by log 6 on both sides. So now these two cancel out, and I'll be left with x is equal to log 12 over log 6. So now log 12, this is the same thing as log 6 times 2. Now I have this over log 6. Now if I have something in the form log a times b, this is equal to log a plus log b. So log 6 times 2, that's going to equal log 6 plus log 2. I have this over log 6. Now this is the same thing as log 6 over log 6 plus log 2 over log 6. So now these two cancel out, and I'm left with x is equal to 1 plus log 2 over log 6. I'm going to again change to log 2 times 3. Now I have x is equal to 1 plus log 2 over log 2 plus log 3. Now log 2, this is equal to 0.301. And log 3, this is equal to 0.4771. So now I have x is equal to 1 plus 0.301 over 0.301 plus 0.4771. So now I have x is equal to 1 plus 0.301 over 0.7781. Now I have x is equal to 1 plus 0.3868. So x is equal to 1.3868. So I have 9 to the power of x is equal to 18, and I want to find the value of x. So the first thing I'm going to do is I'm going to take the log on both sides. So now I have log 9 to the power of x is equal to log 18. And now if I have something in the form log a to the power of b, I can actually move this exponent of b to the front of the logarithm. So this would equal b times log a. So now I have x times log 9 is equal to log 18. And now I'm going to divide both sides by log 9. So then these two cancel out, and I'm left with x equals log 18 over log 9. Now log 18, this is the same thing as log 2 times 3 times 3. Log 9, this is the same thing as log 3 times 3. Now I have x is equal to log 3 times 3 is the same thing as 3 squared, so I have 2 times 3 squared. Now 3 times 3 is the same thing as 3 squared, so I have log 3 squared. Now, if I have something in the form log a times b, this is the same thing as log a plus log b. So in this case, I have log 2 times 3 squared, so this is going to equal log 2 plus log 3 squared. I have this over log 3 squared. Now remember how I said if I have something in the form log a to the power of b, I can move this exponent b to the front, and this would equal b times log a. So I'm going to do this with log 3 squared. I can move this to the front, so this would equal log 2 plus 2 log 3. And I'm going to do the same thing with the denominator, so I have over 2 log 3. Now this is the same thing as log 2 over 2 log 3 plus 2 log 3 over 2 log 3. And 2 log 3 over 2 log 3, that's simply equal to 1. So I have log 2 over 2 log 3 plus 1. Now, log 2, this is equal to 0.301. And log 3, this is equal to 0.4771. So now I have x is equal to 0.301 over 2 times 0.4771 plus 1. Now this is equal to 0.301 over 0.9542 plus 1. This is equal to x is equal to 0.3154 plus 1, which is equal to 1.3154. So this is our answer. Alright, so I have 8 to the power of x is equal to 80. Now the first thing I'm going to do is 80 here. This is the same thing as 8 times 10. So I'm going to replace 80 with 8 times 10. So now I have 8 to the power of x is equal to 8 times 10. Now I can go ahead and divide both sides by 8. So I have 8 to the power of x over 8 is equal to, these two cancel out, so simply 10. Now 8 here, this is the same thing as 8 to the power of 1. And now if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 8 to the power of x over 8 to the power of 1, that's going to equal 8 to the power of x minus 1. This is equal to 10. Now 8 here, this is the same thing as 2 to the power of 3. So if I replace 2 to the power of 3 with 8, I get 2 to the power of 3 to the power of x minus 1 is equal to 10. And now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of x minus 1, that's going to equal 2 to the power of 3 times x minus 1. And now I can distribute the 3. 3 times x is 3x. And 3 times negative 1 is negative 3 is equal to 10. Now, if I take the log on both sides, I have log 2 to the power of 3x minus 3 is equal to log 10. Now, an important property of logarithms is that if I have log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this would equal b times log a. So in this case, I can move this to the front, so I'll have 3x minus 3 times log 2 is equal to log 10. Now I can divide both sides by log 2. So then these two cancel out, and I'm left with 3x minus 3 is equal to log 10 over log 2. Now log 10, this is the same thing as 1. So now I have 3x minus 3 is equal to 1 over log 2. And now I'm going to rewrite this as, well, first off, log 2 here, this is equal to 0.301. So now I have 3x minus 3 is equal to 1 over 0.301. Now 1 divided by 0.301, that is actually going to be 3.3223. Now if I add 3 on both sides, I get 3x is equal to 6.3223. Now I can divide by 3 on both sides, and I get x is equal to 2.1074. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 16 to the power of x plus 20 to the power of x is equal to 25 to the power of x. Now what I'm first going to do is I'm going to divide both sides by 16 to the power of x. So these two would cancel out, and on our left-hand side we have 1 plus 20 over 16, which is 5 over 4, to the power of x is equal to 25 over 16 to the power of x. Now, 25 over 16, well, this is equal to 5 over 4 squared. So squared, and now we have this to the power of x. And this is equal to 1 plus 5 over 4 to the power of x. So now what we're going to do is I'm going to let 5 over 4 to the power of x equal t. So I'm going to assign it to the variable t. And this can actually be, instead of 2 to the power of x, I can actually also write this as x to the power of 2. So I can flip this positions. So now if I replace 5 over the power of x with t, I get 1 plus t is equal to t squared. So now if I subtract t and 1 on both sides, I get 0 is equal to t squared minus t minus 1. And if I plug this into the quadratic formula and factor this, I would get t is equal to 1 plus or minus the square root of 5 over 2. So this means that we already have our value for t, 5 over 4 to the power of x. So this means that 5 over 4 to the power of x is equal to 1 plus the square root of 5 over 2 and 1 minus the square root of 5 over 2. So let's first do 1 plus the square root of 5 over 2. So we have 1 plus the square root of 5 over 2. Now, to solve this, I'm actually going to take the ln of both sides. So if I take the ln of both sides, well, now I could move the x to the front of the ln. So this would be x ln 5 over 4 is equal to ln 1 plus the square root of 5 over 2. So now if I divide ln 5 over 4 on both sides, these two cancel out and I get x is equal to ln 1 plus the square roots of 5 over 2. This is actually 1 plus or minus the square root of 5 over 2 over ln 5 over 4. So this is our answer.